Good morning, Year 8. This is the learning journey I sent you yesterday, which details the lessons that we're going to do over the next couple of weeks. Right, yesterday you did forces. Today we're looking at balanced and unbalanced forces. This is what we're going to do today. So what I'd like you to do first of all is I'd like you to open up your booklet, and what you'll find in your booklet is hopefully your answers. And I'd like you to check and correct yours. So if you just pause the video now, that'll give you time to write down your actual answers and tick yours off. So once again, if we go through this, I'm going to scroll down the information that you're given, and I'm going to leave this on this page, this half, first of all, for you to make a note and copy. And correct your work. So if you pause here, then we're fine. You can correct your work. That arrow shouldn't actually be there. Let's get rid of that. So what we've got here then, just to go through an example. Sorry that these aren't exactly downwards. It was difficult to align my arrow, so it was going directly downwards. So what you've actually got here on the Christmas bauble is you've got a bit of string or wire holding it up, and there's tension in the wire, so you've got a force acting upwards, which is caused by the weight of the bauble acting downwards. Now with this one, I've assumed that the boat is moving forward at a constant speed, so the thrust is the same as the air resistance here, and the weight acting downwards is balanced by the upthrust of the water, otherwise the boat would sink. It gets a bit more complicated here. What we've done is we've talked about the force acting at the nail. The force acting on the nail, okay, is acting upwards, and it is actually equal to the weight acting downwards. But I've drawn these as two forces acting as tension in the wire that's holding the picture frame up. So if you added the forces here and here, then that would total this force, although it's not exactly to scale. So it does get a little bit more complicated when you start looking at books on shelves. You have a force acting downwards, which is the weight, and that is the reaction force is a component of that. Two components here, which is the normal force, which acts at 90 degrees to the surface, and we have friction here. And if we added these two forces together, which we can do with Pythagoras, but you'll do at GCSE, then it's equal to this force here. So moving on, these are the answers to the other questions. So if you pause the video now, you can correct yours. And these are the other answers. I got this one from NASA. I like this one because the actual force arrows are touching the object, which is always useful. And that's what I've tried to get them acting from where the force is. So here it's at the nail. Here it's the center of mass. Here it's where the wire or string attaches to the ball. So moving on quite quickly. This is what you're going to do today. You're going to work through this. So you'll need to read this information, and you'll need to look at these examples. Now this box just represents a free body diagram, which is, it could be anything. Okay, it's just an object. Okay, now two forces are acting on this one, so we both in the same direction, so we add them together. So 5 plus 5 gives us 10. Two forces are acting on this object, one's acting to the right, the other one is acting to the left. So they are in opposite directions, and we use the sign minus to show it's the opposite direction here. So we've got plus 5 minus 5, which equals 0. Once again, we can say 10 plus 10 in that direction. Because this is the opposite direction, this is minus 5, so it's going to be 10 minus 5, which will give us 5 newtons acting to the left. Now you have worked through these before in some previous lessons before the holidays, so these shouldn't cause a problem. What we've got now is we have an object with two forces acting on it. Now if we just do this one, what we've got is we have got, if I insert a text box here, be in anywhere, but oops, there we go. There we go. Right, and what we'll do is just place that onto in front of text there. So what we can do is we can write down underneath here. So you need to, if you want to put some answers onto here, you need to go to Insert, Text Box. It'll drop a text box in, and then when you go to this tab here or this tab here, you can go to in front of text. Okay, now we can then resize and shape that box. I'm going to put it there. So what we've actually got then, I'm going to say that this is plus 20, and this force here is acting in the opposite direction, which means it's minus 5. So what this does is it tells me I've got 15 newtons of force acting in this direction to the left. Okay, because it's plus 15, and plus is to the left. Hopefully that will allow you to do that. With these, you just add these two together, combine them before subtracting or adding to this one. So it's up to you which one you want to make a plus and which one to make negative. Obviously, if we've used plus to the left, you could just make sure that plus is to the left. Now with these, okay, again, to insert text box. There we are, nice and straightforward that time. We can go with, well, we've got 300, so we'll call that plus, okay, 300, sticking to what we did before, minus 340, so that's equal to minus 40 newtons. The object moves to the right. Okay, now I'm going to leave you to complete the rest of these questions. And there are also links in your email which you can use to help you with balanced and unbalanced forces, which will talk you through it. So good luck.